Hello, everybody. Welcome to the first lecture for Sociology 404. So we're going to begin looking at the statistics today. Okay, so we're going to be following the OpenStax textbook, which is just titled Introductory Statistics. So we're going to start in chapter 1, but we're going to kind of breeze through chapter 1 because there's not very much like math in it. It's mostly just like a definition chapter. So we're just going to kind of breeze through some of the more important definitions and not hit everything in there in too much detail. And we'll kind of slow down when we get to chapter 2 and go through it more carefully. So let's start with, what else but the definition of what is statistics. Okay. So what is statistics? You probably had math before, but maybe not statistics. And statistics is very similar to math. It's like a branch of math, but it's in some ways very different from our typical math. Okay. And we'll talk about kind of the differences as we go on, but um, the definition, the textbook definition, like from our textbook, is this. Okay, so statistics deals with the collection, analysis, interpretation, and presentation of data. Okay, and this is a common definition. I think this is actually the same definition they have on Wikipedia. So it's not just unique to this textbook, but let's really break down what this is saying, okay? So everything centers around this data, first of all, which probably isn't surprising since that's typically, how we hear about statistics, right? We hear like 53% of people believe this, yada, yada. That's a kind of data. The collection of data, the analysis of data, the interpretation of data, and the presentation of data. Okay, these are all very important things. The collection of data we'll see is very important because how we collect it could influence our conclusions, right? Maybe if we collect it a certain way, it's going to lead to a lot of bias and we're not going to be able to trust our results. For example, if we want to know who people are going to vote for president, or a better way to phrase that would be if we want to know who is going to win the presidency and we survey only people in Louisville, Kentucky, that's not going to give us a good idea of who's really going to win, right? Because people voting in Louisville, Kentucky might think very differently from people voting in like in California or even in another city in Kentucky. We have the data that Louisville is much more liberal than the rest of Kentucky. So it would paint a different picture. A better way to do it, if we want to know who's going to win the presidency, we would need to survey people from everywhere in the country, right? So that collection part is very important. We want to make sure we don't introduce any bias in our data as much as possible. And we'll talk about what that means later. The analysis of data, right? So, okay, now we have the data. So what do we do with it? Okay. What is important? What is not so important? Okay, that kind of stuff. And then very closely related to that is interpretation. Okay, now we have the data, we know what's important, we know what this data is saying. What conclusions can we draw based on this? Okay. And then finally, the presentation of data. This one is more like, okay, I have my data, I've analyzed it, I have my conclusions, I'm very confident in this now. but it doesn't really matter much if you don't tell anybody else about it, right? Because usually we're doing these experiments in order to influence some kind of change or at least satisfy some curiosity. And a big part of that is, spreading that to other people. We can't really change anything with this data if we don't have other people involved too, so we can show them why things need to change, how things need to change. Um, so how should we present the data? Should we make a bar graph to show it to people? Should we make a pie chart? That's like a basic way of looking at it. How should we communicate our results? Right? Maybe we understand the results, but they're very technical, and we only know because we've studied statistics. But we have to present this to our boss who's never looked at statistics in their entire life. How do we make them understand this? How do we present this to them in a way that they'll understand the importance of it? Okay. So these are the kind of things we're going to be looking at. So let's look at some more definitions here. Statistics is often divided into descriptive statistics and inferential statistics. Okay. So descriptive statistics is where we're not really making any, it's not inferential, so we're not really making any of our own inferences. Let me leave a bit of a gap here. We're merely using it to describe something that's happening. Okay, so we're not really drawing our own conclusions. We're just making observations. Okay, so descriptive statistics is the part of statistics dealing with organizing and summarizing data. Okay. So again, we're not really making our own conclusions here. We're not really trying to say anything about it. We're merely saying, okay, here's some facts. I've organized them to make them look nice. Here's a summary of what it says. I'm not putting my own opinions in it at all. I'm just merely describing this to you. Right? So this could be like demographics or something, like something that doesn't have any opinion in it. Maybe like the test scores. Like if I tell you guys what the average test score is, I'm not making any inferences there. I'm just describing what the data was to you. Whereas inferential statistics I think I spelled this wrong. No, that looks right. Okay, inferential statistics is where we are drawing conclusions. We're making inferences. Okay. So I'm just kind of summarizing what the book says here. It refers to drawing conclusions using probability. Okay, so one chapter we're going to look at in depth is chapter 3, which is dealing with probability. Statistics uses probability quite a bit because we need to know, okay, statistics isn't an exact science. It's not saying this is true 100%. Very rarely is it saying that. It's saying there's like a 90% chance this is true, or something maybe more precise. That's what we're going to use probability for. We're going to say the probability that this is true is very high, or maybe that it's very low. Okay. So these are both equally important. Obviously, inferential statistics could maybe be a little bit more difficult because we actually have to make our own conclusions, use some math, whereas descriptive, we're just organizing and summarizing. But we're going to spend some time on both of these branches. Chapter 2 is mostly dealing with descriptive statistics, and then Chapter 3 on goes more in depth with the inferential statistics. Okay. All right. So speaking of probability, let's really summarize what is probability. Okay. So let me, just so that this doesn't all blend together here, let's change the colors up. Okay, so probability is the study here, a better way to say this would be is a mathematical tool used to study randomness. Okay. So a lot of things in our world happen randomly, or at least they can seemingly happen randomly, right? Like maybe it's not actually random, but when you kind of zoom out and look at everything as a whole, it it feels very random. And in those cases, probability is our best bet of studying it. So this is a tool that we use to study randomness. It's a branch of mathematics. Um, it's not always the most intuitive. There's some surprising things in probability that we'll talk about. But it's important to understand the rules of probability and what it really means to say like that there's a 50% chance when we flip a coin that we're going to get heads and a 50% chance that we're going to get tails. Right? It's important to understand like what those kind of statements mean and then how we can use that to study statistics. Okay. All right, so let's look at some of the key terms. In the book, there's a section called key terms, and there's a lot of terms here that are all going to be very important to us. So let's just kind of go down the list here. Okay. Let's start with a population. Okay. So population, generally when we think of the word population, we think of it as like a collection of people, right? Like if we think about the population in Louisville, we think about like how many people are in Louisville. So that's the definition we're going to use here. It's a collection of persons, things, or objects under study. Okay. And it is slightly different from how we normally think about populations. For example, if we want to study, how do I put this? If we want to study who is going to be, who is the most likely candidate to win the presidential election, and in order to do that, we're surveying people and asking them how they're going to vote. The population is going to be how the people of the US are going to vote. Okay, it's not just the people of the US, it's specifically how they're going to vote. So we specifically want the part that is under study. Okay, so it's not just the people, it's specifically what we're trying to get from those people, which is the information about how they're going to vote. Okay, I think it'll make more sense when we talk a little bit more about examples, so I won't say too much about it now. But very related to population is the sample. Okay. So the population is like the big part, the everything everything that we could possibly be studying. But, if we want to know how people are going to vote and we're studying on our own, there's no way we could possibly ask every single person in the United States. So instead, what we would do is we would take a sample. We would just take a part of it, probably a much smaller part of it, and look at that sample and try to um, make inferences based on that sample and relate them back to the population. So the sample is the small thing and the population is the big thing. So in other words, the sample is a subset of the population. Okay. So going back to like the collection of data and the definition of statistics, this is what we mean by it's how we collect it is how we collect that data is very important. In other words, how we make our sample, how we take our sample is very important. And what we're going to see is we should make sure that we have a big enough sample and that it's a random sample. Okay. So, this is just laying out the definitions. We'll go more in depth about what these things mean in the later chapters. So these are just like putting these definitions in our toolbox to take out later. Okay, so that's why I'm just kind of stating the definition and moving on. Let's talk about a statistic. Okay, so not the branch of mathematics called statistics, but what do we mean by a statistic? Like, here's some statistics for you to read. What does that mean? Okay, so a statistic is a number that represents a property of the sample. Okay. Okay. So statistics and samples go together, right? Statistics are numbers that represent something about the sample. Okay. So whenever you read about statistics, it's typically about a sample, right? If we read that like um something like 75% of people in the US enjoy music. That's not that person who came up with that statistics, they didn't actually ask every single person, right? They took a sample of the population and asked that sample. So 75% of the people in their sample did enjoy music, right? So that 75% is a statistic because it's about the sample. When we talk about it, we usually talk about it as if it's referring to the entire population. Whether or not that's appropriate to do will depend on some other things we'll have to determine later, that we'll talk about later. So when can we use them interchangeably like that? And, most people don't. So how can we look for that when we're reading about studies? Okay. So a number that represents property of the sample is a statistic. So there must be a name for the number that represents property of the population. And there is, that's a parameter. Okay. But it's a little more than that. A parameter is a number that represents a property of the population. Okay, but then also it can be estimated by a statistic. Okay. So like I said, we take the sample and then we use that to kind of extrapolate that into saying something about the population, right? So we look at statistics of the sample, and then we use statistics to estimate what the parameters would be. Okay. So like for example, maybe let's say that there was 20 people in this class, which there isn't, but let's say that there was, and I grade the first 10 tests, and I find that the average on the first 10 exams that I graded randomly was 75%. Okay. That's a statistics because that is a number that's talking about the sample, the first 10 tests. And then I say, okay, based on this statistic, I believe that the parameter, the average of all of the exams, is also 75%. Okay. So whether or not I'm right, I can't know until I grade the rest of them. But that's what we're doing here. We're trying to guess what the parameter is based on the statistic. Okay. So we typically don't actually know what the parameter is because in a lot of cases it's impossible. Like if we're talking about, something about like the whole US or the whole world, there's just too many people to really know what that parameter is. Maybe on smaller scale study, we can. So the population goes with the parameter, just like the statistics goes with the sample. Okay. Um, and typically, I guess we'll mention it more later, but with statistics, we typically represent those with our alphabet, and with parameters, we typically represent those with the Greek alphabet, right? So like the um the average of the entire population, we would typically represent as the Greek letter mu, whereas the average of a sample, we represent with the letter X with a bar over it. Okay. But I'll talk about that later when we start actually doing that. But I just want to let you know that in case like you are reading ahead or you see it in like a study or something, whenever they're using Greek letters, that typically refers to a parameter, and whenever we're using our letters, that typically refers to a statistic. Okay. So when we're taking the sample, I mentioned earlier, we typically want it to be large and random. Okay. We want the sample to be as large as possible, and we want the sample to be taken randomly. And if we do that, ideally, we come up with what's called a representative sample. Okay. It's in the book, but I'm not going to write down the definition. But a representative sample is just exactly what it sounds like. It's a sample that represents the entire population. Okay. So there's different ways we could take the sample in order to try to come up with the representative sample, but ultimately that's what we're doing is we're trying to come up with a representative sample. Um, we have to be careful not to try to force it because that's a bad type of sampling, which we'll talk about. But the idea is if we do it randomly, as long as our sample is large enough, it will naturally become representative. Okay. All right. So next is one you've probably heard before in a related context, not this exact same context, but a variable. Okay. So we typically think of a variable as like x or y in algebra, right? Like x plus 3 equals 5, find x kind of thing. Or a better example would be like y equals x plus 3, right? Like we have a line where there's an independent variable and a dependent variable. So this definition is related to that, but not exactly the same. It's like it's just worded differently. So a variable, I'll write that after. A variable is a characteristic or measurement that can be determined for each member of a population. Okay. And this is usually denoted in statistics specifically, it's usually denoted by a capital letter. Okay. So this is a little different from like algebra. We don't typically use capital letters. In statistics and probability, we do because the lowercase letters are used like how they are more traditionally used in algebra or to represent things like the statistics. Okay. Um, so the big difference with this definition of variable as opposed to how we're used to it is that it's a little more broad. Because notice it says it can be a characteristic or a measurement. So a characteristic doesn't have to be a number, right? So this allows for variables that are non-numerical. Okay. If we think about the measurement part of it, then our old definition of variable, like in algebra, still works, right? It's like a number that can be determined, like depending on the context of what the variables mean in algebra. It's the same kind of definition, but this is a little more broad to allow for things that are not numerical. Okay. So this is like essentially like what we're studying. Okay. It's like if we want to know, if people are going to vote Democrat or Republican, then the variables would be like Democrat or Republican, right? That's what we would write for the variables. If we wanted to know what the most common hair color in like Louisville is or something like that, then the variables would be like blonde, brunette, whatever. So it doesn't have to be a number necessarily anymore. But of course, we do want to distinguish between the ones that are numbers. So we have the names numerical variables and categorical variables, which, this is exactly what it sounds like. The numerical ones are the numbers, the categorical ones are the non-numbers. Okay. Now, we do have to be a little careful when we talk about like numerical being numbers and categorical being non-numbers, because sometimes we use numbers to refer to things, but we don't mean it in a numerical way. What I mean by that is if we have a survey, right, and we pick 1, 2, 3, 4, or 5, or this is like strongly agree, and this is the other end to strongly disagree, then like we're technically using numbers here, but they're not really numerical. A good rule of thumb is if we can take the numbers that we're getting and like add them together and subtract them and we still get like something meaningful, then they're probably numerical. Otherwise, they're probably categorical. So in this case, it's not really numerical. We're just using the 1, 2, 3, 4, and 5 as like shorthand for the strongly agree and the strongly disagree and so on. Again, we'll talk more about the nuances there as it comes up. The next one is a very important one. Let's see if this shows up well. Yeah, I think that shows up okay. Data. Okay. So data are the actual values of the variable. Okay. And this, at the end of the day, is ultimately what we're trying to figure out, or what we're studying, right? We are looking for data, and we're using data we're studying data, right? Data is plural, so the singular is datum, right? But we're hardly ever talking about a datum, right? Or a datum, or data, or data. We're hardly ever talking about just one of them, so we typically always use data. Okay. So again, like, because these are referring to any variables, it doesn't necessarily have to be numbers. It could be characteristics, or it could be numbers. The book talks a little bit here about mean and proportion. So I'll just briefly talk about it, but we're going to talk about this much more in depth in chapter 2. So I won't say too much about it. But the mean, okay. The mean is, in a sense, the average, right? We typically think of mean as being interchangeable with the word average. And that's to say, like, if I have some data, like I have these 3 numbers here, and I want to know the average of them, what I would do is I would add them up and divide by however many there are, right? That's typically what we think of as average. But to be more precise, this is the mean, right? And this would end up being 7. Average is a little more general. Average can typically refer to 3 different things. It could be the mean, the median, or the mode. For example, if sometimes, like with the most typical hair color in Louisville, we would state that as what's the average hair color. And we can't add up the hair colors and divide by however many there are, right? So in that case, when we're talking about average, we'd actually be talking about the mode, which is the most common one of them. So this is more generally called like the measures of center, meaning where is our data the most concentrated, which is one of the topics in chapter 2, descriptive statistics. So it's good to mention it now, though, just because this is such a common word. So when we're talking about mean, this is typically what we mean. We mean add them all up, divide by how many there are. And I'll go into more detail with that with more examples later. I won't ask you to calculate it yet. Proportion, though, this one, you should know how to calculate during this part of the class. Proportion. What do we mean by proportion? Well, we mean how many of something do we have in relation to how many there are, okay? Or how many, maybe not like that we have. Let's say we're talking about what's the proportion of people in the class who received an A, okay? And then we say like, okay, 7 people got A's, right? We have 7 people get A's, 8 people got B's, 10 people got C's, 8 got D's, 7 got F's, let's say. And this is actually what's called a frequency table, which I'll talk about in 1.3. What is the proportion of the class with A's? Okay. So we want to know how many people got A's in relation to how many people total are in the class, right? So we know 7 people got A's, and when we say in proportion to, that means divided by. So 7 people got A's, and then we divide that by how many people are in the class. So we can go through and add up the 7, the 8, the 10, the 8, and 7. 8 plus 7 is 15. So we can do like 15 here is 30, plus 10 is 40. Right. So 7/40ths of the class got A's. If we want a more meaningful answer, we can pop that in the calculator here. This would be 0.175, and you should know how to turn this into a percent. So this is 17.5%. Okay. So the proportion of the class with A's, we might say 7/40ths, we might say 0.175, or we might say 17.5%. Okay. Those are three different, these right here are three equivalent ways of saying that. I think often we gravitate towards percentages because it's, I guess, just easier for us to like visualize. But you can write your answer in any of these three ways here. Okay. All right, that's pretty much all of chapter 1. Like I said, I didn't go in as much detail as the book, so I still encourage you to read it. And that's section 1.1, not all of chapter 1. So be sure to go through that more carefully than we did here if you're not feeling too comfortable with it yet. And then, yeah, I think 1.2 is a little bit too long to fit into this video too, so I'm going to cut that into another video. So I will, I'll see you guys for that one. We'll talk about 1.2, and yeah, thanks for watching.